Hello viewers, tutorial 14 question 12, also repeated as tutorial 15 question 15. So we have a kinematics problem here. We have an object being dropped from the top of the sky tower. The height of the object as a function of time, so t would be measured in seconds after the object was dropped, and the height would be given with the ground as a reference measured in meters. So the height is, s as a function of time, is 328 minus 4.9 t squared. How high is the sky tower? Well, the height of the sky tower must be the same as the height of the object as it was released, which would be at time 0. So we need to work out what the height is at time 0, so we can substitute in 328 minus 4.9, substitute in 0, so we get 4.9 times 0 squared. 328 minus that is 328 metres. Part B, how high is the object after 3 seconds? So we want the height, so we are dealing with s. When time is 3, we get 328 minus 4.9 times 3 squared. And that turns out to be 283.9 metres. Part C, how long does it take the object to land? Well, it lands when it hits the ground. When it hits the ground, what's the height? The height is 0. So we're trying to find out what value of t makes s of t equals 0. So s of t equals 0 tells us that 0 equals 328 minus 4.9 t squared. We need to solve that for t. So therefore, 4.9 t squared, if we move that term to the other side, equals 328. So if we divide through by 4.9, we get t squared equals 328 divided by 4.9, and then we'll take the square root of that. It's going to land after it was released, not before, and therefore t must be positive here. So we don't need a plus or minus. So therefore t is, if we calculate that, we get 8.18 seconds. So it takes the object 8.1 seconds to hit the ground. Part D, find an expression for the velocity of the object. Well, that means we need to get from the height to the velocity. That is a job for differentiation. So v is going to be the derivative of s, which is we need to differentiate 328 minus 4.9 t squared. 328 is just a number, differentiates to 0, so it'll be negative 4.9 times 2 is 9.8 t to the power of 1. So that's an expression for the velocity, or the speed with a direction. That negative tells us that the object is moving downwards. How fast is it falling after 3 seconds? So we want the velocity at the 3 second mark. So we need to substitute t equals 3 into that velocity function we just got, which was 9.8 times t, and if we calculate that, we get negative 29.4, and this is measured in meters per second. Part F, we need the acceleration. Okay, so to get from velocity to acceleration, well, acceleration is the rate of change of the velocity. It's how fast the velocity is changing, which means it's a job for differentiation. So acceleration is the derivative of v, which means we're differentiating your velocity function, which is negative 9.8 t. Differentiating that, we just get negative 9.8, which looks very familiar because that is the value of the acceleration due to gravity. Okay, thanks for watching. Over and out. First, let's do the units of the acceleration, meters per second squared. Okay, thanks for watching.